Hello ho ho. Yeah, welcome back to another video. Finally, it's been a while. But yeah, we are back for another video. Yeah, and this one serves as a warm-up because yeah, I have to get back into creating videos and all sorts of things. So yeah, today I will kind of explain the plane swap algorithm using Python or PyCharm, but Python. But no matter what language you are familiar with, that doesn't really matter. You can do it in Java and C. I try to explain everything like it is viable for any language because I'm more focused on the algorithm in general and not on the code. Okay, algorithm is called a plane swap algorithm, and yeah, maybe you are here because you have to study it for university task or something similar. Maybe you have it at school, but I don't think you have to learn this at school. But prove me wrong if I'm wrong. Anyways, if you are not having to study it, you should always know how this algorithm works because yeah, it's a great foundation. You can use it in designing or programming games, maybe, or in 90.9% of all cases it's already included, but then you maybe want to know how it works. And yeah, it's kind of a foundation for more complex algorithm. Let's start. So what do we want to do? If I'm not totally stupid and I forget about this, here you will see a little picture of segments. And yeah, these segments are lines, vertical or I can't pronounce that. You know if they are straight. So these ones, the horizontal lines. Okay, let me ask Google.
Horizontal.
Horizontal. Okay, got it. And as you can see, I already have the code. So what I'm gonna do is I simply explain it. Maybe post it somewhere so you can copy it. But yeah, most best effect is if you simply type it down. When I study, I always have to write anything down because otherwise I won't get it into my head. So even if someone explains something to me, I have to yeah, write it down. Okay. Now to the code. We have the function or the algorithm which is called plane swap, and yeah, as an input, depending on the language, we have two lists or arrays. One that includes a horizontal segment list and a vertical segment list. What are segments? Segments are the lines I already told you about, but yeah, in later algorithms it also can be squares or similar things. So yeah, but in this case we have only horizontal and vertical lines, no in between. And yeah, we create a list that is empty at first with events. So what is an event? An event is, in case of the horizontal lines, when a line starts or when it ends. Yeah, and in terms of the vertical lines, it's simply the line itself. And yeah, for that we loop through the horizontal lines first. And there we divide the horizontal elements in elements that, or we don't divide them. We analyze each segment, and yeah, we append our first empty event list. We append two types of events, the left and the right ones. I'm marking them. This is important because yeah, we have the ones where the line starts and where the line ends. And we really need this if condition, otherwise it won't work if the start point and the end point is not always, start point is not always smaller than the end point, because yeah, a line can start at x5 and end in x1. So, or it can start in x1 and end in x5. And that would confuse us if we simply append the start and the end points, because we have to move forward and backwards. And for that, we have this little if conditions. So if the x1 is bigger than the x2, we simply swap them. And after that, the first one, the smaller one, will append that with left as a kind of type, and the other one with white, because it's a white point. Now, after we have done that, we also want to add the segment as a vertical segments to our events. Here we for each horizontal element, I will repeat it, we add 2 events, and for the vertical segment list, we add 1 event. And after that, the events need to be sorted. So how will they be sorted? Pretty simple. First off, a segment, where do we have an example? First and most important is first information of the event, which is x coordinate. Endpoint and start points have one x coordinate, then the type, left or right or vertical, and then we have the segment. It's where it was expected from, or where it was, the kind of source of the event. So the horizontal events have only have an x coordinate, and the vertical segment lists, even if they have 2 y coordinates, are also sorted by their x element. Yeah, that's important. And because it's the first information, lower values will put to the front, higher values will put to the end of the list. And so that is everything regarding the hierarchy. If we have similar coordinates, the second information or the second element is the one that counts now. And it's sorted according to the alphabet. So first left, then right, and last the vertical one. Okay, so after being sorted, we create new 2 empty lists. The y list will help us first, and the result list is the one that we will return when we are finished. Okay, so now we have created and sorted the events, and we can now loop through the events using a for loop. In Java we are simply using for loop, I guess. And here in Python we can using the triple, because they are kind of saved in a triple, and we can simply divide it. First we have the variable, the x variable, which is the x coordinate. Then we have the type variable, which is the type. And then we have the segment, which is this one here, which is also a triple. Okay, according to the data type, it's a tuple, but when I refer to triple, I simply refer to a tuple containing 3 elements. And so we are creating these 3 variables out of the event. The event is simply each event we get while looping. So type, as already mentioned, can be left, right, or vertical. If it's left, we add, we simply have y, a coordinate, which is a segment, this part here. And this will be sorted, or will be added in a sorted way inside the y list. And that's if we have the event left. If it is the y, if we have the event right, we will also have we will also create this variable. Now what is important, this segment and this segment, these two, can be the same if they refer to the same segment. So as already mentioned, for each horizontal segment list we create 2 events, and yeah, these events, so if we loop through the events, each horizontal segment will be looped through twice, or will be accessed twice, because it contains a left and a right event. And yeah, if we get the left event of the segment, we will add something to y, and the same the one we added to y will be removed. So the first time we access the segment through its event, we will add it to y, and yeah, after that, the second time we will move it to y. But what is interesting, if during that time, so if the segment is still inside our list. And here is the third case, that is if our type is a vertical element. Now again, we have our segment. This one, the underscore simply means we don't need the first element of the segment, so it will be ignored. And yeah, it creates a list of the y coordinates. And with y coordinates, I mean the y coordinates of the y list. And he will simply see if there are any bisections, or if there are, to be more specific, if there are lines that meets. So if a horizontal line meets or is cut by a vertical line. I hope I made it clear what we are looking for. So if there are 2 lines that like each other and they occasionally met in an orthogonal, in a mathematical way, they love each other, and so they will be listed. And that's why they have to be inserted, so we get each in the right direction and the right sequence. Oh, here's a fly. Oh no, it was a mosquito, but anyways. Yeah. And finally, when we found such bisection, intersection, we append it to our result. And yeah, that's it. And here I have 2 examples. We create such by, here we use plane swap for our 2 lists. Again, as already said, we have a horizontal list of horizontal triples and a list of vertical triples. And here we test it. And if I hope you can see it. Yes, you can see it. We have intersections with the horizontal element that starts at 1, ends at 5, and yeah, is at y.2, and the vertical element that is also in x2, which is between 1 and 5. Yeah, and is itself starts from 1 to 5 in case of the y coordinates, and yeah, the y coordinates 2 is between these 2. So it's obvious that they should meet each other, or be bisected, or intersected. I don't know if bisect or intersect is the right word. Here we get the same for 0, 3, 4, which because 2 is between 0, 3, and 1, 5 is between 5. And if we look at 2 elements, for example, these ones, we see, for example, if we want to see if this one and this one meet each other, we see 1 to 5. 1 and 5 is between 3, and 2 is between the 0 or 3. So this one and this one should make a pair. Let's see. Here we go. Here we have the pair. So yeah, that's simply it. That is our cute little algorithm. Oh, 50 minutes, not bad. Yeah. And yeah, in the future, until I feel ready again to live stream, this will be the content. I hope it's not too boring. I think it's something to kill time, or maybe you get I guess most of the people who are listening to that will view these videos because they have to study it. Yeah. So with that in mind, see you to the hopefully we meet at the next video. Bye bye. Hello ho ho test. Yeah. Hello ho ho. Okay, I will start over again.